So you probably remember the old Nike saying, just do it. Well, today we're just going to undo it. So we're going to build on our order of operations and those number tricks we did. And we're going to show how undoing the order of operations, kind of working backwards through them, helps us to solve an equation. So a little funny story that I want to share with you. My daughter Emma was playing with her friend Rowan, and they were playing math number tricks. And Emma said, oh, here's my number trick. I'm going to pick my number, and I'm going to add 3, multiply by 7, subtract 4, divide by 2, add 1. And when I do it, I get 13. And her friend Rowan thinks for a minute and goes, I think your starting number was 1. And Emma goes, no way! How did Rowan do it? Well, let's think about what Rowan did. And the way we're going to approach this is we're going to take a look at a quick table, and we're going to work through our expression. So here's the idea. What happened was Emma picked a number, and she did those 4 operations to it, 5 operations. Well, let's generalize it. So with our expression, we're going to say, well, we're not going to pick a number. Let's pick x. And then what we're going to do is we're going to build our expression, build our number trick using the order of operations. So we'll take x, and we'll add 3 to it. We'll get x plus 3. Then we're going to multiply by 7. Be careful. Remember, it's the quantity x plus 3 that we're multiplying by 7. Then from that quantity, we'll subtract 4. Then we take all of that, and we're going to divide it by 2. And then our final step is to add 1 to this big old fraction. So this is our number trick that we're going to do. And we were told that the result was 13. So check this out. If we know that doing this number trick gives us 13, let's undo the order of operations to see what we get. So I'm going to start at this 13 here, and I'm going to work my way zigzagging up the table. So from the 13, I'm going to say, well, instead of adding 1, let's subtract 1. So 13 minus 1 gives me 12. Now let's keep undoing. Instead of dividing by 2, let's multiply by 2. And when we do that, we get 24. Keep undoing. Instead of subtracting 4, let's add 4. 24 plus 4 is 28. Keep undoing. Divide by 7. 28 divided by 7 is 4. Keep undoing. Then we'll subtract 3, and 4 minus 3 is 1. And we don't have any more undoing to do, so we're happy. So we've just seen how undoing the order of operations can kind of be the same as solving an equation. And actually, you just solved this equation. That's the equation you solve. Because can you see the number trick in here? If I start here at this x, I added 3. Then I multiplied by 7. Then I subtracted 4, divided by 2, and added 1. So when I go to undo all that, what I'm going to do the undoing is I'm going to start by subtracting the 1, then multiplying by 2, then adding the 4, then dividing by 7, then subtracting 3. So that's going to be my undo. Now let's show you how that works. Let's subtract 1 from both sides of the equation. We know that those cancel out, so I get this big fraction here, and all that equals 12. So that was done. Now let's get rid of this one. Multiply by 2. So 7 times x plus 3 subtract 4 is equal to 24. So now I'm going to add my 4. Let's keep going with the undo. Adding 4. 7 times the quantity x plus 3 is equal to 28. Now, I know you're probably saying, well, what about the distributive property here? Yeah, sure, you can do that. I'm just going to keep undoing, though. We'll get to the same result. If I divide everything by 7, I get the quantity x plus 3 equals 4. And you know what? I don't really need those parentheses, so that's okay. Last undo step, subtract 3, and we get x equals 1, which was this number that Emma started with. So hopefully you can see the connection between undoing the order of operations in an expression is how we really solve equations.